we're going to go a little bit over some of the things that we had at the very end of last week's lecture, and we're going to go over another example. Let's look at example 2 in last week's example, and we had our first GUI, and this, because it was among our first examples, we had everything was in the GUI. That's not normally going to be the case, and it won't be the case for your assignment. You will have to be calling code in other classes, and we'll see how to do that in the second example today. What this did is this converted Fahrenheit to centigrade and centigrade to Fahrenheit, depending on which button you pressed. All right, and you can do this several different ways. The way that I chose to do it was to have a different listener for each of the two buttons. So I'll go to the command line. So we can see it run. So I'll compile this. In this example, we have two buttons, and each have been assigned their own listener, and we can convert from centigrade to Fahrenheit. And we type in the right value. Or we can convert Fahrenheit to centigrade. So we had two different listeners, and therefore we did not make first GUI class implement the action listener interface, unlike the other example. If you remember the other example, the first GUI implemented it, and therefore the code that processed the action performed when the button was pressed was contained within this class. Here we use a thing called an internal class, or we have something called C2F, and that is a class that is inside of our other class. We rarely put multiple classes in a single file. This is one example where it's okay to do it because this code is sort of tied to the GUI. In other words, this code is not necessarily going to be reusable code. It's a code that will only work with this GUI with all the things named that way. So we assign the listener as a new instance of the C2F class, and the C2F class is defined here. It implements action listener, and because it implements action listener, it must have the action perform method that does its thing, and its thing is to grab the value from the text box and convert it from centigrade to Fahrenheit and display the answer. The other thing we do is we use what's called an anonymous class. In an anonymous class, we don't even give the class a name. We define the class right smack dab in the middle of the add listener function. So we add an action listener of this class type. It's a new action listener, and its action perform method is this. So that's the second way we can add a listener to a button in this example. We create an anonymous class. The argument to this is, in fact, a brand new object that we're creating that has no name. But the class definition is right here. We notice when we compile these, we get a couple extra files. We get first class $C to F. That is for the internal class named C to F. First GUI $1 is an anonymous class because it doesn't have a name. All right, let's look at our next example. And our next example is the next example is a little game. And we have multiple classes in here. We have our GUI class, which is a high-U GUI. We have our test code, which is separate from the GUI. We have our game class, which is actually the rules of the game. And then we have a dice class, and we have a dice test. So let's go over this. All right, when I wrote this, first thing I did is I created a dice class. And let's look at that dice class. A dice class represents all the things I want to be able to do with the dice. A dice has an attribute of the face value. When I create a dice, I automatically roll it. I can roll it and get the face value after I roll it by generating a random number. And I can return whatever number was generated. But how do I know this works? How do I know that it randomly generates 1 through 6? I wrote a separate test class for this. So making sure my component works. What I'm going to do is I'm going to loop through and I'm going to roll this dice 10,000 times. And each time through the loop, I have a case statement here, which is a way to do an if statement. We look at this variable. If it's equal to 1, we increment this counter, 2, increment this counter, all the way down through 6. And then at the very end of the loop, we print out how many times it rolled each of the numbers. And if we notice if there was a bug in one of these, like for example, it didn't add up to 10,000. Or if there were way more ones than there were 2s, 3s, 4s, or 5s, 6, then we know that there'd be a problem with our dice. So let's compile our code and run the Java dice test. And if we look at this, it's very close to an even distribution. Not exactly even, but then again, if you roll dice 10,000 times, it wouldn't exactly be 1/6 of the time for each, but it's pretty close to that. We could up that if we wanted to. It's 10,000. Let's do 1,000,000 rolls of the dice. Hope that doesn't take too long. And there we notice it's closer to even. And the higher number of dice that we roll, the higher or the closer that it will get to be even. We rolled this 10 million times. We notice again that it's even closer still to being fairly even. All right, so now I'm happy that my dice are fair. It's not skipping a number. It's not rolling one number substantially more than another number. So I know my dice component works. This is the importance of unit testing. We did unit testing already on the pizza classes that you have for your assignment. So we know that those functions work. So you don't have to do that in this example. I think I've given you a unit test class. I then have a game class. And the game that we're doing is a very simple game that's called high-low. Let me run the GUI and show you the way it works. You start off with 100 points. You can choose that the value of 2 dice will either be low, which means that when I roll 2 dice, it'll be number 1, or value 2 through 6. 7, which when I roll the 2 dice, the value will be 7. Or high, which the value of the dice will be 8 through 12. Now, if you bet low or high and you win, you get paid even money. So if I bet 1 point and I win 1 point. If I pick 7 and it's 7, because the odds are smaller for it to be 7 than the other 2, I actually win 4 to 1. So let's run this. I'm going to pick and say that I think it's going to be high. Roll the dice and I win. So I'm up to 101 points. I'm going to pick low. I won again. I'm going to pick 7 this time. I'm on a roll. I should buy a lottery ticket today. Okay, finally I lost, showing that it is possible for me to lose in this game. Now, how do I know that this game works? All right, I wrote a unit test for it. All right. So the unit test for the logic is in this high-low game object. And I put the test code in the high-low game test. Let's look at the high-low game logic. I have 2 dice, which are created. I give my choice, whether it's high, low, or 7. The values are 0, 1, or 2. And if the value is not between 0 and 2, it's an invalid option. So I throw an exception. Otherwise, I roll the 2 dice, sum them together, and I have some if statements. If I bet 0, which means the player chose low and it's less than 7, I win. Otherwise, I lose and I've lost whatever much I bet. If I roll a 7, if I pick 7 and I roll a 7, I get paid 4 to 1, which actually, this is another case where the house has the advantage here, because the odds are 6 to 1 against getting it, and they're only paying you 4 to 1. And likewise, if I pick 2 and the value is over 7, then I've won. Otherwise, I lost. How do I know this works? All right. I want to make sure that this code works before I bother testing the GUI. Because if this code is producing bad results, then I know that the GUI can't possibly work. I want to eliminate what could be causing me the problems. So each class I wrote, I'm going to write a test class for to make sure that that works. And in this case, the test class looks like this. I'm going to play 100 games. And each game I'm randomly going to pick 0, 1, or 2. I'm going to bet 1 point. I'm going to roll the dice, see what my pick was, see what I bet, and see if I won or not. And I'm going to make sure I'm going to make sure that the result, I'm going to inspect to make sure the odds that it shows up the right, that the results that it got are consistent. So let me compile this. It's a little harder to test this because there's randomness involved. So I'm going to run 100 iterations. And see Java. All right, and I can inspect. There's my 100 game results. I can look through them. All right. Picked 1, which means it's 7. Picked a 7. I rolled a 10. And I bet 1, therefore I lost 1. I picked 7 again, and I rolled a 7, therefore I win 4. I pick 7, and I roll a 1, 2 ones, so that's 2, and I lose. So on down the line. I'm looking at this and my test code seems off because I'm never picking a 0. Well, let me look at my test code and see if there's a problem with it. I should do this instead. That was done by accident, by the way. I didn't intend that to be a bug. But that's something I noticed from our testing. Hey, I didn't test that because the results didn't show any of those zeros. And out of 100 games, I should get some where I picked the low value. Now, if I look at this, well, there's some cases I'm picking a 0, I'm picking a 2, picking a 2, a 0, picked a 1. Okay, so that is more meaningful. I'm doing a better test because I'm actually picking all the possibilities. And I noticed that, again, if I picked high and I rolled a 9, I win. And so on. So I'm confident that that works. Now I can test my GUI to make sure that that works, or now I can write my GUI. So let's take a look at the GUI. All right, I have all my stuff here. I have a label, all the points. I have the label to make a choice. I initialize my points at 100. I have my options as being make choice, low, 7, and high. I make my combo box from that list. I have a label for the dice 1, label for dice 2, a label for the results. I create an instance of the high-low game. All right. Now, one thing you're going to have to consider for your pizza example is, are you going to create your objects up here, or are you going to create them when the button is click? You'll create your order object like I'm creating my high-low game object here at the beginning as a property because I only need one order object when I'm ordering the pizza. That is just sort of an assumption for this assignment. Every time I click the button, though, I'm going to need to create a new pizza. So I have my game object here. Standard GUI kind of stuff. Add my action listener to be this. Again, when I do that, then this object needs to be an action listener, and I'll include that action performed method as part of this class. I could do it any of the ways that I've shown you in the first two examples. Creating my panels, adding them there. I set a layout along the y-axis, so things will be oriented vertically. I have these little mini panels, though, that are going to be oriented horizontally. If we're going to draw this, it's going to look like this. My main panel, the one that I'm going to set, is P. That is oriented along the y-axis or vertically. So my P panel is oriented vertically. These other things that I add to it, I add label points to it. That's going to put the label for points up here. I add to P choice the label, the option list, which is a new thing that we've covered. It's a drop down, and the button to play. I've added all that to the P choice panel. Then I add, and that is oriented horizontally. So then I add the P choice panel to this, and that'll have the label, drop down, and the button. I have the label for results underneath that. I have a label for dice, or a panel for dice, by default oriented horizontally, and I'm going to put the two dice side by side. I add all those two panels to the main panel, so I get the other panel. My GUI is going to be like this. Label for points. Text that says make selection, the drop down, the button, the label for the results, the two dice objects. So let's see what happens when we click the button. We've already created that object up here. We've created it outside of any functions. So this is a object level variable. It has scope anywhere in the class. By scope, I mean it is available to be used. If I declare a variable inside a function, it can only be used inside that function. In this case, I've declared that variable outside of any function with the list of attributes at the beginning. Therefore, G could be used anywhere throughout the class. Action performed. So when the button is clicked, we have an integer for user choice, the bet, and the payoff. We get from the dropdown which option was selected. And that's going to be an index. In other words, its position in the list. So what's going to display to the user is going to be these three choices: low, 7, and high. We're going to get the index or position, and we're going to subtract 1 from it to get it to be what we want it to be, because we don't want it to be 1, 2, or 3. We want it to be 0, 1, or 2. Pardon me. Let me silence my phone. Oh, it was already? Okay. So here we get the index. That's the position of the item that was selected in the dropdown. We subtract 1 of it to change that from, instead of 1, 2, and 3, to 0, 1, or 2. How do I know all this? Well, I can look up. Java JCombo box. And I could get look at the methods here. And what method did I call? I called get selected index. We learned it's the first item that matches the given item. So it's a selected value. Now, the very first item, actually the numbering starts with 0. But if you remember, the very first item is simply an option that says, make your choice. We don't want the user selecting that. We only want these 3, which are, this is 0, this is 1, this is 2, and this is 3. So we subtract 1 from it to get what the choice is going to be, because our object is expecting 0, 1, and 2. We're going to assume the bet's 1 point. We call our payoff equals G play. What is G? That is a high-low game object. We give it the user choice in the bet. If the payoff is less than 0, then we lost. If the payout is greater than 0, then we won. We increment or decrement the number of points. We set the label. We then display the image name in this manner by setting an icon on the label. That's an easy way to get an image on a page. Notice that the names of the dice are simply D1, 2, 3, 4, 5, 6, 7. Or not D1, 2, 3, 4, 5, 7, D1, 2, 3, 4, 5, 6. And therefore, we simply take the value of the dice plus D plus JPEG, and that forms the name of the image that we're going to use. Set those icons, and there we go. Now let's talk a little bit about your work. For your work, we're going to just assume that you're going to enter the pizzas for 1 order. All right. So when you declare your class, I'm not going to create a whole class, but you're going to declare at the top of the page an order object order equals new order. This along with all the J buttons and everything that you need. In your action performed method, you're going to get the values from the different items on the entry screen. So you're going to get the size with pepperoni or not. And what else? The type of crust, if we have that. You're going to get that from the different elements of the form. You could have drop downs, you could have radio buttons. You're then going to create a new pizza object because every time you click the button, that means that a new pizza is added to the order. So we're not going to declare the pizza class up here, we're going to declare the pizza class here. So every time we click the button, we're going to create a new pizza. And we're going to initialize the appropriate fields in the constructor. And then we're going to add that pizza to the order. Don't quote me on these names of methods. I'm not doing it with the code right in front of my face, so I could be getting them wrong. We then can get the bake time and display it on the screen. Or the order cost and display it on the screen. That's how your example is different than this one. In this example, I only had one class that I was interacting with, the game class. And I only needed one of those game classes. So therefore, I created it at the beginning. You're going to only need one order, and every time you click the button, you're going to add a pizza to that order. So every time you click the button, you're going to create a new pizza object and add it to the order. There's some other items I want you to take a look at this week in Canvas. Went over this. We have a radio button test. This is code that shows you the value of a radio button. I showed you a drop down in this example. This will show you how to do a radio button. I create my radio buttons and I add them to a button group. And then I add each of the radio buttons to a panel and display it. I then have code on the action performed to display what radio button got selected. Notice they work as a unit because I put them all in the radio button group, even though I individually put the radio buttons on the panel. Click run, it will show me that button with a value of 3 was picked, which is B3. 2, B1. So to summarize, I have my radio buttons. I have my radio button group. I add the radio buttons to the radio button group. I add the radio buttons to a panel. Then I have a code that tells me which one was picked. If first one was picked, second one or third was picked. This is sort of more advanced. Here I'm looping through to find out which button is selected, and I'm displaying the text off the button that got selected. This is a better way to do it because this will work if you have 6, 7 buttons. If you add more buttons, you don't really have to change the code, but this is a little more complex. But effectively what we're doing is we're looking at each button and we're looping through those buttons and seeing which one is selected and displaying the text for the button that got selected. For our purposes, if you do something like this, that's acceptable, the brute force method. What else do we have here? Sort of an extra challenge in the next assignment is to create a scroll pane. Let me show you what I mean. Here I've counted up to 100 or from 0 to 99, and I've put it in a panel that can scroll. How do you do this? I've just looped through. I've created a new label each time through the loop and displayed, added that to a panel. Panel is part of a J scroll pane. So I've added that panel to the J scroll pane. I've added the J scroll pane to my frame. And therefore, every time I add something new to the panel, if it exceeds the length of the screen, it will scroll. Finally, I've done something with enumerations here. For example, in the student example that we've been doing, we've had, IC equals in county, LC equals, or IC equals in county, OC equals out of county, OOS equals out of state. There's a better way to do that. There's a way that you can define these are the allowable values for this variable. And that's called an enumeration. I did that in the pizza class, where I've just defined that the pizza size can be one of these 3 things: small, medium, and large. And I've declared the size as not of type string, but of type this enumeration. I then can test to see if the pizza size is medium, small, or large. If you use an enumeration, that prevents someone from setting a value for the size that's not a valid size. When it was a string, we could give it a value of something that wasn't illegal. We could say, instead of small, medium, or large, we could say extra large or gigantic or whatever. So this shows you how you can create an enumeration and limit the values for this particular variable to be one of these three. And I even have a unit test that shows how that tests out. So instead of setting it to large, I set it to, in the pizza class, the pizza enumeration, I want the large value from that. So you put the name of the class it's in, name of the enumeration, and the value that you want. Please take the time to go over these examples. I know I just sort of introduced them to you, but take a look at them and see how they could benefit you in the things that you have done and the things that assignments that you'll have to do in the future. Are there any questions? If there are no questions, that's all I had for this week. We'll talk to you next week.